WISIWYG is an acronym for, What You See is What You Get. In computing, a WISIWYG editor is a system in which content on screen during editing appears in a form closely corresponding to its appearance when printed or displayed as a finished product, which might be a printed document, web page, or slide presentation. Meaning, WISIWYG implies a user interface that allows the user to view something very similar to the end result while the document is being created. In general, WISIWYG implies the ability to directly manipulate the layout of a document without having to type or remember names of layout commands. The actual meaning depends on the user's perspective. For example, in presentation programs, compound documents and web pages, WISIWYG means the display precisely represents the appearance of the page displayed to the end user, but does not necessarily reflect how the page will be printed unless the printer is specifically matched to the editing program, as it was with the Xerox Star and early versions of the Apple Macintosh. In word processing and desktop publishing applications, WISIWYG means that the display simulates the appearance and represents the effect of fonts and line breaks on the final pagination using a specific printer configuration, so that, for example, a citation on page 1 of a 500-page document can accurately refer to a reference 300 pages later. WISIWYG also describes ways to manipulate 3D models in stereochemistry, computer-aided design, and 3D computer graphics. Modern software does a good job of optimizing the screen display for a particular type of output. For example, a word processor is optimized for output to a typical printer. The software often emulates the resolution of the printer in order to get as close as possible to WISIWYG. However, that is not the main attraction of WISIWYG, which is the ability of the user to be able to visualize what they are producing. In many situations, the subtle differences between what the user sees and what the user gets are unimportant. In fact, applications may offer multiple WISIWYG modes with different levels of realism, including a composition mode, in which the user sees something somewhat similar to the end result, but with additional information useful while composing, such as section breaks and non-printing characters, and uses a layout that is more conducive to composing than to layout. A layout mode, in which the user sees something very similar to the end result, but with some additional information useful in ensuring that elements are properly aligned and spaced, such as margin lines. A preview mode, in which the application attempts to present a representation that is as close to the final result as possible. History. Before the adoption of WISIWYG techniques, text appeared in editors using the system's standard typeface and style with little indication of layout. Users were required to enter special non-printing control codes to indicate that some text should be in boldface, italics, or a different typeface or size. In this environment there was very little distinction between text editors and word processors. These applications typically used an arbitrary markup language to define the code's tags. Each program had its own special way to format a document, and it was a difficult and time-consuming process to change from one word processor to another. The use of markup tags and codes remains popular today in some applications due to their ability to store complex formatting information. When the tags are made visible in the editor, however, they occupy space in the unformatted text and so disrupt the desired layout and flow. Bravo, a document preparation program for the Alto produced at Xerox PARC by Butler Lampson, Charles Simonai and colleagues in 1974, is generally considered the first program to incorporate WISIWYG technology, displaying text with formatting. The Alto monitor was designed so that one full page of text could be seen and then printed on the first laser printers. When the text was laid out on the screen, 72 ppi font metric files were used, but when printed 300 ppi files were used. Thus one would occasionally find characters and words slightly off, a problem that continues to this day. Bravo was never released commercially, but the software eventually included in the Xerox Star can be seen as a direct descendant of it. In parallel with but independent of the work at Xerox PARC, Hewlett-Packard developed and released in late 1978 the first commercial WISIWYG software application for producing overhead slides, or what today are called presentation graphics. The first release, named Bruno, ran on the HP 1000 mini-computer, taking advantage of HP's first bitmapped computer terminal, the HP 2640. Bruno was then ported to the HP 3000 and re-released as HP Draw. By 1981, Micropro advertised that its WordStar word processor had WISIWYG, and in 1983 Weekly Reader advertised its Stickerbear educational software with the slogan, "What you see is what you get," with photographs of its Apple II graphics. In the 1970s and early 1980s, however, most popular home computers lacked the sophisticated graphics capabilities necessary to display WISIWYG documents, meaning that such applications were usually confined to limited-purpose, high-end workstations that were too expensive for the general public to afford. Towards the mid-1980s, however, things began to change. Improving technology allowed the production of cheaper bitmap displays, and WISIWYG software started to appear for more popular computers, including Lisa Write for the Apple Lisa, released in 1983, and Mac Write for the Apple Macintosh, released in 1984. The Apple Macintosh system was originally designed so that the screen resolution and the resolution of the image writer. Matrix printers sold by Apple were easily scaled, 72 ppi for the screen and 144 dpi for the printers. Thus, the scale and dimensions of the on-screen display in programs such as Mac Write and Mac Paint were easily translated to the printed output. If the paper were held up to the screen, the printed image would be the same size as the on-screen image, but at a higher resolution. As the image writer was the only model of printer physically compatible with a Macintosh printer port, this created an effective, closed system. Later, when Macs using external displays became available, the resolution was fixed to the size of the screen to achieve 72 dpi. These resolutions often differed from the VGA standard resolutions common in the PC world at the time. Thus, while a Macintosh 14 inches monitor had the same 640x480 resolution as a PC, a 16 screen would be fixed at 832x624 rather than the 800x600 resolution used by PCs. With the introduction of third-party matrix printers as well as laser printers and multisync monitors, resolutions deviated from even multiples of the screen resolution, making true WISIWYG harder to achieve. In 2012, Wikipedia offered a WISIWYG editor called Visual Editor, which allowed edits to Wikipedia to be performed without seeing the page source. Etymology, the phrase, "What you see is what you get," from which the acronym derives, was a catchphrase popularized by Flip Wilson's drag persona Geraldine, first appearing in September 1969, then regularly in the early 70s on The Flip Wilson Show. The phrase was a statement demanding acceptance of Geraldine's entire personality and appearance. As it relates to computing, there are multiple claims to first use of the phrase. The phrase was coined in 1982 by Larry Sinclair, an engineer at III, to express the idea that what the user sees on the screen is what the user gets on the printer while using the page layout system, a pre-press typesetting system first shown at ANPS in Las Vegas. John W. Sable and researchers at PARC were simply reappropriating the popular cultural reference. The phrase was popularized by a newsletter published by Arlene and Jose Ramos, called WISIWYG. It was created for the emerging pre-press industry going electronic in the late 1970s. After 3 years of publishing, the newsletter was sold to employees at the Stanford Research Institute in California. Problems of implementation, because designers of WISIWYG applications typically have to account for a variety of different output devices, each of which has different capabilities, there are a number of problems that must be solved in each implementation. These can be seen as trade-offs between multiple design goals, and hence applications that use different solutions may be suitable for different purposes. Typically, the design goals of a WISIWYG application may include the following: provide high-quality printed output on a particular printer, provide high-quality printed output on a variety of printers, provide high-quality on-screen output, allow the user to visualize what the document will look like when printed. It is not usually possible to achieve all of these goals at once. The major problem to be overcome is that of varying output resolution. As of 2007, monitors typically have a resolution of between 92 and 125 pixels per inch. Printers generally have resolutions between 240 and 1440 pixels per inch. In some printers the horizontal resolution is different from the vertical. This becomes a problem when trying to lay out text. Because older output technologies require the spacing between characters to be a whole number of pixels, rounding errors will cause the same text to require different amounts of space in different resolutions. Solutions to this include the following: always laying out the text using a resolution higher than the user is likely to use in practice. This can result in poor quality output for lower resolution devices, but provides a fixed layout, allowing easy user visualization. This is the method used by Adobe Acrobat. Laying out the text at the resolution of the printer on which the document will be printed. This can result in low quality on-screen output, and the layout may sometimes change if the document is printed on a different printer. This is the method used by Microsoft Word. Laying out the text at the resolution of a specific printer on which the document will be printed using the same font information and kerning. The character positions and number of characters in a line are exactly similar to the printed document. Laying out the text at the resolution for the output device to which it will be sent. This often results in changes in layout between the on-screen display and printed output, so is rarely used. It is common in web page designing tools that claim to be WISIWYG, however. Other problems that have been faced in the past include differences in the fonts used by the printer and the on-screen display and differences in color profiles between devices. Related acronyms: many variations are used only to illustrate a point or make a joke, and have very limited real use. Some that have been proposed include the following: WISIWYG, what you see is more or less what you get, recognizing that most WISIWYG implementations are imperfect. WIZ-ee-wig, what you see is almost what you get, similar to WISIWYG. SIAK, what you see is all you get, used to point out that advanced users are sometimes limited by the user interface. WIZ-ee-wig, what you see is what you mean. WISIWYG, what you cache is what you get. WISIWYG turns up occasionally in the address bar of Gecko-based web browsers such as Mozilla Firefox when the browser is retrieving cached information. Unauthorized access to WISIWYG documents was fixed by Mozilla in Firefox version 2.0.0.5. WIZ-ee-wig, what you get is what you see, used in computing to describe an interaction paradigm in results-oriented user interface. The term was used by Jacob Nielsen to describe Microsoft Office 2007's ribbon interface. WIZ-ee-wig, what you see is what you need relates to software, which is not composed through the interconnection of modules, but work with such a detailed user and rights management, that users can see only what they really need. WISYHYG, what you see you hope you get, a term ridiculing text mode word processing software. Used in the Microsoft Windows Video Collection, a video distributed around 1991 on 2 VHS cassettes at promotional events. WYSIWYG, what you see is probably what you get, relates to HTML and markup editors where code and macro tags sort of show what the result will eventually be. This type of WISIWYG view is hard to render while editing, so the user can only guess at the outcome. WISES, what you see is what you sign, an important requirement for digital signature software. It means that the software has to be able to show the user the content without any hidden content before the user signs it. WYSIWYG, what you see is what you deserve, refers to the ability of the user and of course his effort to create something worthwhile. WYSIWYG, what you see is what you want, used to describe GNU/Tex Max editing platform. The abbreviation clarifies that unlike in WISIWYG editors, the user is able to customize WYSIWYG platforms to partly act as manual typesetting programs such as TeX or TROF. AVHI, you asked for it, you got it, used to describe a text command-oriented document editing system that does not include WISIWYG, in reference to the fact that users of such systems often ask for something they did not really want. It is considered to be the opposite of WISIWYG. The phrase was first used in this context in 1983 in the essay Real Programmers Don't Use Pascal to describe the TECO text editor system, and began to be abbreviated circa 1993. WYSIWYG, what I see is what I type, also used to describe text-oriented editing systems in the opposite sense of WISIWYG. See also, plain text, list of HTML editors, comparison of HTML editors, does exactly what it says on the tin, tableless web design, references. External links, the jargon file entry for WISIWYG, what has WISIWYG done to us? A Eurocritical paper about the negative effects the introduction of WISIWYG has had as of 1996. XML, WISIWYG to ʻwɪziwɪɡ A brief look at XML document authoring. An article on existing XML authoring software, atpm.com's WISIWYG, is it what you want?